Statistical data analysis is the process of collecting and analyzing data to gain useful information and support decision making. In this study, 496 policyholders were selected from a total of 1338 observations. The data include age, gender, BMI, number of children, smoker status, region, and medical insurance charges. The analysis aimed to identify factors that affect medical insurance costs. Descriptive statistics are used to summarize the data, while the inferential statistics such as t-test and ANOVA are used to compare the different groups. For example, the study compared smokers and non-smokers, males and females, and people from different regions. The result helped insurance companies and healthcare providers understand what influences insurance costs and makes better decisions regarding pricing and risk management. In conclusion, statistical data analysis help turn raw data into useful information for better decision making.
Assalamualaikum. My name is Norashika Sahira binti Muhammad Saiti. My metric number is A23A2188. Now, I would like to continue with the SPSS sampling and data collection framework. In this phase, we focus on unbiased selection and dataset integrity validation. To ensure that our analysis is fair and representative, we apply simple random sampling or SRS using IBM SPSS statistics. This method gives every individual an equal chance of being selected, which helps to minimize selection bias. For the sampling strategy parameters, we selected 496 respondents from a total population of 1,338 cases. Since each case had an equal probability of being chosen, the sampling process was objective and reliable. Next, under the variable classification schema, the variables were divided into two categories. The first category is scale variables, which include age, body mass index or BMI, and annual insurance charges. These are numerical variables that can be measured continuously. The second category is nominal variables, which consist of gender, smoker status, and region. These variables are used to classify respondents into different groups. Moving on to the SPSS operational sequence, the first step was importing the dataset into SPSS. After that, we used the select cases function under the data menu. Then we selected the random sample of cases option and specified a sample size of 496 records. The unselected cases were removed from the analysis and the final sample dataset was saved separately for future analysis. Overall, this process ensured that the dataset used in our study was unbiased, systematic, and suitable for further statistical analysis. Next, I will explain the core statistical discoveries and inferential tests obtained from our analysis. In this phase, we focus on measures of central tendency and risk factor modeling. First, under the descriptive central tendencies, we summarize the numerical variables based on a sample size of 496 respondents. The average age of the respondents was 39.51 years, with a median value of 40 years and a standard deviation of 14.07. For the BMI index, the mean was 30.75, the median was 30.40, and the standard deviation was 6.06. Meanwhile, the average annual insurance charges were Rm 30,545 and 47, while the median was Rm 9,630 and 23, with a standard deviation of Rm 12,304 and 41. The noticeable difference between the mean and median of insurance charges indicates that the data is positively skewed, suggesting the presence of several extreme values of outliers. Moving on to the inferential modeling and hypothesis testing, we conducted an independent sample t-test to examine the effect of smoking status on insurance charges. The results show that smokers had a much higher average insurance cost of Rm 30,229 and 35, compared to RM 8589 and 20 for non-smokers. Since the p-value is less than 0.001, we rejected the null hypothesis and conclude that smoking status has a significant impact on medical insurance charges. In fact, lifestyle factors, particularly smoking, appear to be the strongest predictor of higher insurance costs. Next, we perform a one-way ANOVA to determine whether insurance charges differ according to region and number of children. The findings show that both variables were statistically insignificant as their p-values were greater than 0.05. Therefore, we can conclude that geographical region and the number of dependents do not significantly influence insurance pricing. Overall, the analysis revealed that smoking status is the most influential factor affecting insurance charges, while region and number of children have no significant effect.
Assalamualaikum warahmatullahi wabarakatuh. My name is Izwan. So today I will present about descriptive statistics. For the first one is I will talk about numerical descriptive statistics are used to make statement about the general feature of a set data. So they give an overview of the distributions, center tendency, position, and variability. So, descriptive statistic for numerical is focusing on three continuous variable. Is about age, body mass, index, and medical insurance charges. So, I will cover central tendency, position, variation, and the visual summary that help us interpret these results. Next is a measure of the central tendency. So we'll summarize a typical or central value in the data. So for the age, mean is 39.51 years, median 40 years, mode 19 years. The mean and median are so close, which suggests the age of distribution is fairly balanced. So we're looking for the BMI. For the BMI, mean is 30.775 and median 30.40. For mode is 26.60. For the mean for BMI is at 6. The mean BMI are at 6, the healthy range, indicating many respondents may be overweight or obese. So that is about medical insurance charges. For mean is 13,545 ringgit 47 cent, and median is 9,630 ringgit 23 cent, and for the mode is 1,639 ringgit and 56 cent. So because of the mean is much higher than the median, so the charges are positively skewed, and a small number of a very high cost pull the mean upward. Next is about measure of position. Quantiles show where observation fall relative to the whole sample. So we're looking for the H quantiles is Q1 equal to 26, Q2 median equal to 40, Q3 equal to 53. So this means about 25 percentage of respondents are 26 or younger, and for the 75 percentage are 53 or younger. So we're looking for the BMI quantize. Q1 equal to 26.72, and Q2 equal to 30.40, and for the Q3 equal to 34.42. So for the half of respondents have BMI between 26.72 and 34.42. Okay, for the insurance charge quantize, okay, for the Q1 is 4,686 ringgit and 74 cent, and for the Q2 is 9,630 ringgit 20 and the 23 cent, and for the Q3 is 17,824 ringgit and 96 cent, and for the half of the policy holders pay between roughly 4,687 ringgit and 17,825 ringgit annually. For the last one is numerical descriptive measure is measure of variation. Variation tell us how spread out the values. The value are around the center. So for the age is variance is 212.76 years. Standard deviation 14.59 years. And the range is 18 to 64. For the range is equal to 46 years. This indicates a broad age spread. So for the BMI, its variance is 35.58 and standard deviation is 5.97, and range is 15.96 to 49.06. So there is a moderate variability in BMI across respondents. So for the medical insurance charges, for the variance is 151 million and 398,404 ringgit and 10 cent. So for the standard deviation is 12,000 and 304 ringgit 41 cents. For the range is 1,137 ringgit 1 cent to 63,770 ringgit 43 cent. For the range is equal 62,633 ringgit 42 cent. So the very large of the variance or sorry so the very large variant and the range confirmed is substantial differences in cost, likely driven by the factors such as age, health status, and the lifestyle. So next we move on to the graphical representations. So this slide we will talk about the visual representation, make it quick and easy to see the pattern for distribution and relationships within the dataset. So for the most important variable in this dataset are shown in the following charts. So to make this pattern easy to see, we use the pie charts for categorical distribution and histogram for the continuous variables such as age, BMI, and insurance charges. So now for this slide, these pie charts are clearly show the relative proposition. Pie charts clearly shows the relative proportions of categories. For example, smoker versus non-smoker or gender breakdown. So they are useful when you want the audience to grasp share or composition at a glance, and the visual each slide is labeled and the legend is visible so small categories are not overlooked. So next for the histogram for the graphical representation. So for continuous variables such as age, BMI, and insurance charges, when the presenting point to the histogram for insurance charges to highlight the positive skew and to the BMI histogram to show how the concentration above the healthy range. And so we can see, for example, point to the insurance charges histogram to show the positive skew. Most policyholders cluster at lower to moderate charges, while a small number incur very high costs. Then call out the long right tail and any visible outliers. And for BMI, emphasize the histogram's concentration above the healthy range to show how many respondents fall into overweight or obese categories, and and notate the healthy range cutoff on the x-axis so the audience can immediately see the proportion affected. And when presenting this chart, so to improve the clarity by using consistent with uh, with clear axis labels, including units such as Ringgit Malaysia for charges and contrasting color for important groups. Consider adding vertical lines for the mean and median, text callouts for quantities or notable outliers, and a brief caption that summarizes the takeaway for each chart. And for highly skewed variables like insurance charges, a log scale, or an accompanying box plot can make the distribution easier to interpret while preserving the message that a minority of policy holders drive much of the cost. Thank you.
Salam sejahtera doktor. My name is Dinesh Analaki Kalidas. My matrix number is A23A2004. Today I'm gonna brief my part, which is infantile statistic. Our analysis have shown of 496 randomly selected policyholder from the SPSS report reveals which lifestyle and demographic factors truly drive medical insurance costs. Firstly, an independent sample t-test proved that smoker status has a massive statistically significant impact on pricing, which is P lower than 0.001, with smokers paying an average of 32,229 Mayer compared to just 8,588 Mayer for non-smokers. In contrast, biological gender does not significantly alter costs, which is P equals to 0.140, as the slight variation between males 14.3k and female 12.7k falls entirely within the margin of error. Moving to our regional health metric, a one-way ANOVA confirmed that BMI levels vary significantly across geographic zone, which is P lesser than 0.001, identifying that policyholder in the southeast region carry the highest average BMI at 32.8. Finally, When testing actual premium charges against location, which is P equals to 0.525, and the number of dependents, which is P equals to 0.507, our ANOVA model, show no significant differences, meaning neither geography nor family size acts as a primary cost driver. Ultimately, these findings dictate the risk management and pricing structure should prioritize actionable lifestyle habits like smoking cessation over fixed demographic traits. That's all from me. Thank you, Doctor.
In conclusion, this study analyzes factors affecting medical insurance just using a sample of 496 policyholders selected from a population of 1,338 observations. Several statistical measures we have including descriptive analysis, t-test, and ANOVA. From the descriptive result, the average age of respondents was about 40 years old, with a mean BMI of 30.75 and an average annual medical insurance charge of 13,545.47 Malaysian ringgit. The data also showed high variation in medical charges among individuals. The t-test results showed a significant difference in insurance charges between smoky and non-smoky, with smokers incurring much higher costs. However, there was no significant difference between males and females. For the ANOVA result, BMI differed significantly across ages, with the southeast ages showing the highest average BMI. However, insurance charges did not significantly differ by region or by the number of children covered. Overall, smoking status was identified as the most important factor influencing medical insurance charges. Other factors such as gender, region, and number of children were not significant predictors of insurance costs. Their findings highlight the strong impact of lifestyle factors, especially smoking, on healthcare expense. The result can help insurance companies and policy market improve risk assessment and develop better pricing and health strategies. Thank you.